Okay, so in this video, I'm going to talk about how to understand the 2x2 table and 6 different types of questions that can be asked, such as the sensitivity, specificity, positive predictive value, negative predictive value, odds ratio, and relative risk. Disclaimer, I got this question from USMLE-RX, and all the information and knowledge I have on the subject is from Dr. Randy O'Neill. I used his videos, and you can look him up on YouTube if it's easier for you. Okay, but let's get started. So the question is, the consumption of red meat is examined in a study on the incidence of colorectal cancer. 1,000 subjects were enrolled in the study, and the results are shown in the table. Okay, so I just picked this question. I kind of made my own questions from it. So these are the questions I have. So in order to understand the 2x2 table, you got to know some important things about them first. So if we draw a 2x2 table, right, I'm going to have it like this. Whenever you're making one or you're asked to make one and they don't give it to you, on the top part is always going to be the reality of what is happening. So this is real life. What is happening in the table above? Well, colorectal cancer, it's a real life thing, right? This is reality. And on the left side, you're going to write the test. So whatever the test is measuring. So what are they testing here? Well, they're testing if red meat causes colorectal cancer. So the test is red meat. So that's going to be what the test is going to be. And it doesn't have to be a test necessarily, but it's got to be a factor that they're looking for, like the change in the variable. So also with a 2x2 table, you have to know that you have to do a plus minus and a plus minus, always. So, in order to distinguish between, when they always talk about A, B, C, and D, you have to know what goes in each box. So, what does A represent, what does B represent, C, D, etc. So, since this is reality and since this is the test, this is how you have to look at these boxes. So, you always ask the question first, what is the test testing for? So, what is the result of the test? So, if the test is positive, you know it's a positive result. And if the test is negative, it's a negative result. But what does that mean? So you take the test and you compare it to reality. Okay, so if you have a test, right, and the test comes back positive, and in reality, the person actually does have colorectal cancer, say it's a positive test, you're going to write in the box, it's a true positive. The test is actually true and is a positive test. Okay. Now, if the same person, right, takes the test, comes back positive, but in reality it's negative, well, okay, what does that mean? So the test is saying it's positive, so you know it's going to be positive, but in reality, is the reality true or false? Well, the reality is false. It's not agreeing with what the test says. The reality doesn't agree with the test, so it's false. Okay, so this is going to be a false positive. Now, in the box down here, you see the test comes back as negative. Okay, if the test comes back as negative, but in reality, the test is positive, was the test accurate? No, the test was wrong, so the test is wrong. So it's false, and is the test saying it's positive or negative? Well, the test saying it's negative, so it's a negative. If the test says something is negative, it's negative. But in reality, if it's positive, well, it's going to be a false negative because it's against what the test says. Reality says otherwise. Now, box D, same thing. You go to the test first. The test comes back as negative, right? In reality, it actually is negative. You see over here. Well, if reality says negative and the test says negative, you know it's true. But is it true that it's positive or is it true that it's negative? Well, they're both saying it's negative, so it's going to be a true negative. Up here, both of them agree with each other, so it's positive, so you know it's a true positive. Here, both of them agree with each other, so it's true, but they both agree that it's negative, so it's a true negative. If the tests do not agree with each other, meaning the plus and minus aren't the same, you know it's false, right? It's not correct. So positive, negative, false. Positive and negative, false. Now the only thing you have to differentiate is if it's positive or negative. So that's basically how I understand the table. Now let me clean this up a little bit. I'm going to redraw it. Okay, so with this table, you know that there's multiple different equations that we could be tested on. What are these types of equations? Well, I don't really memorize the equations too well because it gets kind of confusing for me. So I follow this like schematic that I saw on YouTube, and it's very helpful. So this is how the schematic goes. So if we're testing for sensitivity, right? We're testing for sensitivity. What are we really testing for? Well, we're testing for if something is ruled out. What does that mean? So if the person's result comes back as positive, right? The actual test of the person is a positive, or reality is positive. The sensitivity is testing whether the red meat, so our test was on red meat, is the contributing factor or not. So we're trying to rule out what is good or what is bad. Okay, so how are we going to distinguish that? Well, they have an equation that you do. They say A plus A over C or something like that, but I just draw the arrow. I just draw an arrow following down. This is how I memorize it. I circle 100 and I draw an arrow down. What does that mean? So for sensitivity, I'm going to do the top number, 100 that I circled, over 100 again, plus 25. So that's I'm going to figure out what the sensitivity of an equation is. Okay, not too bad. Now for specificity, I'm just going to do the complete opposite. So I'm going to write specificity in green. And what is specificity trying to do? Well, I'm trying to rule things in. I'm trying to see why not eating red meat contributes to not having colorectal cancer. So I'm trying to rule it in. So what am I going to do? I'm going to circle this one. I'm going to go up. And you don't have to really know which one they're talking about if you just have the graph. If you draw the graphs right, like this, with the positive and negative with reality and the test, you could always just memorize the boxes or the formulas I'm drawing. Okay, so specificity is going to be bottom right to the top. So what is this going to be? We're going to do 475 on the top, because that's what I circled first, over 475 again, plus 400. Okay, and that's how I'm going to, this is how I'm going to determine what the specificity is. You have to it's math that you have to do eventually, which is unfortunate, but you'll have a calculator on the exam, and it'll be 100 over 125. Okay, and I'm going to plug these into the calculator because I don't know it off the top of my head. So 100 over 125. For sensitivity, we're going to have 0.8. This is going to be our sensitivity. Okay, and then our specificity is going to be 475 divided by 475 divided by 875. 875, okay. And we're going to end up with 0.542. Okay, so this is going to be our specificity. Now, we know how to figure out sensitivity and specificity. Now, how do we figure out positive predictive value or negative predictive value? Okay, so if we're talking about the positive predictive value, what are we going to do? Well, we have to look for the positive, right, because that's what they're asking us for, and we're predicting it, so we're going to circle the positive ones, right? But we're predicting if y, they go against the reality, the negative side. So you just go from top left to the right. Okay, because you circle both of the positives, you know this is where your starting point is, and you're just going to the right. Okay, so PPV, positive predictive value, is going to be 100 over, 100 plus 400. You're going to get 100 over 500, which is going to equal, pretty sure it's 0.2. I'm not going to use a calculator, but I think it is. Now, negative predictive value is going to be the same thing. But what are we going to do? We're going to circle the two negatives, right? And we're going to go to that box. So that's this box. And if we're going negative, we're just going backwards. So we're going to go this way. So NPV is negative predictive value. And it's going to be 475 on the top, because that's what I circled first, over 475 plus 25. And that's going to equal 475 over 500. And put that in the calculator, 475 over 500 equals, okay, so our negative predictive value is going to be 0.95. I'm going to check what PPV is just in case I got it wrong. 100 divided by 500, it's 0.2. Okay, good. All right, so this is how we find our sensitivity, specificity, positive predictive value, and negative predictive value. Now, practice question with sensitivity and specificity one more time. So we know how we derived it all, right? Now we just have, what if we have to work backwards? So what does that mean? A 45-year-old woman is referred to a neurologist for workup of suspected myasthenia gravis. She undergoes a test to detect the presence of acetylcholine receptor antibodies. Okay, who cares? I shouldn't say who cares, but for the question, the test has a sensitivity of 80% and specificity of 90%. The prevalence of myasthenia gravis in the patient's community is 50%. Okay, so we have all this stuff. If the test is positive, okay, so they're asking for something positive, which of the following is the most likely probability that the patient actually has myasthenia gravis? Okay, so what are they asking us for? Well, they're asking us to find the positive predictive value. Remember PPV. Okay, so does the prevalence matter to us in this scenario if we're looking for PPV? No, we said PPV was what? Something to do with the 2x2 table. Okay, so if they're asking for PPV, let's automatically draw a 2x2 table. Okay, you might say, they didn't give us one, well, draw your own. It makes it much more simpler for you to understand. Okay, so now it says sensitivity and specificity. That's what they gave us. But they also gave us a couple things. They gave us the reality, right? And what is the reality? Well, if she has myasthenia gravis, right? This is what's happening in the clinical field. So you know it's going to be has or doesn't have, so positive or negative. And then what else does it give? Okay, it gives us a test. They say there's a test that predicts if it's positive or negative. Okay, so we're going to do positive or negative. So they gave us the basis of the chart, or the backbone of it, I should say. They also gave us sensitivity is 80%. Interesting. And they said specificity is what? 90%. And you're like, holy crap. What could I do now? I have no other numbers but percentages. They also said the prevalence was 50%, if you want to write that down. If it were me, I would not write this down because I don't think this is going to help me at all, so I'm crossing him out. But it's up to you guys. So now, sensitivity is 80%. I like working with percentage with hundreds. Some people like ones, like using tens. Some people like decimals. I like going in the hundreds. So if it says 80%, I know it's going to be equivalent to 80, right? Because, 80 over 100 is 80%. And if they say 90%, I know the number is going to be 90. Because 90 over 100 is 90%. Okay, but we have to remember, what is sensitivity? So sensitivity was this column, right? This box going down. And we remember what specificity was. Specificity was this box coming up, right? Because sensitivity predicted what was included, and then specificity predicted what wasn't included. Okay, so if we know those two variables, we could determine where the numbers go. So, sensitivity, first one, 80%. That means this box over this box has to equal 80%. Well, how are you going to do this? So, what I do, because I always like working in hundreds, I'll put 100 down here, right? And I'm going to say, okay, so if this box has to equal 80, right? Because 80 over 100 is going to equal 80%. What has to go in this box? Well, it can't be 100 because you know the total, the sum is 100. So it's got to be 20. Now, how do you do the sensitivity, just to double check? You do this box over this box, right? You just circle it, you go down, and you do 80 over what? 80 plus 20 equals 80 over 100, which equals 80%. So boom, sensitivity, we have it down. All right, now specificity. How are we going to do this one? Okay, what did we say specificity was? We said the bottom right box going up. Okay, so we know it's got to equate to 100. Let me draw this in black. It's got to equate to 100. So we know it's got to be 90% as well. So I start off with 90. I'm like, okay, well, if this is 90, and 90 over something has got to be 90%, what's going to go in this box? Can't be 100, because that's what the sum is, so it's got to be 10. So you could do 90, just to test yourself. Just test if you got it right. Circle that box, go over. Go 90 over 90 plus 10 equals what? 90 over 100 equals 90%. Okay, so now, boom, you have sensitivity, you have specificity. How are you going to determine PPV? PPV was positive predictive value. We said for positive predictive value, go to the two positives, and you go from the positives to the right. Shouldn't be too bad then. So if you do that, you go 80 over 80 plus 10, which is going to equal to 80 over 90. Okay, well, what's 80 over 90? Well, let me go on the calculator and put it in because I don't know math like that. Okay, so 80 over 90 is going to equate to 0.89, which you have to, if the stem or the question is given to you in percentages, you know you multiply by 100. So you do 0.89 times 100 equals 89%. That's why I like doing things in hundreds, because you just multiply or divide by 100 to get back to your starting point. Okay, so we're at 89%. So the answer is going to be what? 89%. Now, if they ask us for the negative predictive value, right? What is negative predictive value? Well, we just go to the two negatives and we go to the left. So we would do 90 over 90 plus 20, which equates to 90 over 110. And let's put it in the calculator because I don't know it. Okay, that equals 0.818, which equals what? 0.82 if you round it. Multiply it by 100 to get it into percents because that's what you do. And that equals 82%. So NPV, negative predictive value, would be 82%. Positive predictive value? No, sorry. Positive predictive value is 89%. What is this 80%? Well, sensitivity, they gave it to us, so that's wrong. 11%, you would not get this for anything. And then there is sufficient information. So that's how you break down that question. Now, to talk about, odds ratio and relative risk. Okay, so before we talk about a question, let's discuss what these things are. Accordance right now. And it's going to say, what is the odds ratio? So what is the odds ratio? Or what is the relative risk? So what the hell do these mean? Not too bad. What do they mean? So before we break them down, I just want to break down how a question is going to stem. Because if they don't say what is the odds ratio, they could say, in a study that looked for something, what is the case control? Okay, so it's a case control study. What is a case control study? Well, a case control study really could care less if someone gets it in the future or not. So they don't care about the future, really. What do they care about? Well, what they care about is what they have, because it's a case control. They already have the case. They have what the case is. That means they already know how many cases there are. They know who has it. They know who doesn't have it. That means it's a retrospective. What does retrospective mean? It's looking to the past. Okay, so they know who has it. They know who doesn't have it. So all they're looking for is the percentages. Okay, how do I remember case control is odds ratio? Well, case control, C, or A and O, right? Well, these letters aren't the same. They're at ends with each other. They're at odds with each other. Okay, so that means odds ratio. A and O are not the same letter. This is stupid, but it helps me remember it for some reason. Okay, so what is odds ratio? Well, what are the odds? Something over something else, right? Just one number over another number. What are the odds? I don't know if you guys sports bet or not, but that's how I think of it. What are the odds something's going to happen? Now, relative risk, right? This is going to be a cohort study. How do I remember that relative risk is cohort? Well, O and O are the same as R and R. Relative risk, OO, same thing. I don't know why, but this helps me remember. But let's go on. What type of study is this looking at? Well, a cohort study, no one in the population, or no one has disease, so no one has the disease yet, right? Okay. Well, they're looking at what is the risk of someone getting the disease. What is their relative risk of getting the disease? So they could look into the past, so they could do retrospective. So like, okay, well, if this and this and this happens, what's the risk of getting something? Or they could look into the future. If they do this, that, or that, or this, and this, what could happen to the future? Okay, so relative risk is honestly like a parlay. It's like a gamble. They can do one number over two numbers. So like A over A plus B, right? Two different numbers. And that's what cohort and relative risk is. Well, what the hell does this mean? How can you differentiate how do you figure out this in an equation? Well, we're going to go through it right now. Okay, so now if we go into it, here's the question. A randomized clinical trial is testing the effectiveness of a new influenza vaccine. Okay. 100 participants received a new vaccine. So 100 new vaccine. 100 participants. Okay, another 100 receive a placebo. Oh boy. At the end of the study, 18 out of the 100, so 18 out of 100 who received the placebo, and then 9 out of 100 who received the new vaccine developed influenza. Okay, and now we're asking for the relative risk. Okay, well, I'm going to add something to the question. I'm going to ask for the relative risk, and I'm going to ask for the odds ratio. I want to do both. I want to do both formulas. Okay, we're going to start off with the question asked, though. We're going to say, what is the relative risk of contracting influenza in those who received the new vaccine compared to those who received the placebo? Okay, let's erase this so it doesn't get all clustered. Break it down slowly. Well, what's the first thing we could do? Well, when we talked about these questions, I said always make a 2x2 box, right? I think it's the most effective way to do them. I don't really understand without it. Okay, so what did we say is on the top of a 2x2 box? Well, it's going to be the reality, right? The reality is always put that on top, and what? The test is going to be on the left. All right, so what's the reality? Well, the reality said back in the study, vaccine, no. Placebo, no. No. Oh, influenza. Okay, so the reality is going to be influenza. And it's going to be whether you had it or you didn't have it, right? Positive or negative. So now the test, what's the test? Well, they didn't really say they tested anything, but they performed something. So how did they control it? Well, they did a shot, right? The vaccine, I'm sorry. So someone took a vaccine and someone took a placebo. Well, how does this fit into the graph? Well, test, so if it's a positive test, we're going to say that's the vaccine. And if it's negative, we're going to say that's the placebo because they didn't give them anything. They didn't treat it. It was just negative. All right. I'm going to erase this, prevent the cluster. Okay, so we have our plus and minuses, right? Actually, let's keep the vaccine here for now. Let's keep placebo here for now. Okay, so now how do we plug the numbers in? Well, let's go back. A randomized clinical trial is testing the effectiveness of a new influenza vaccine. 100 participants received a new vaccine. Okay, so 100 people received that. And 100 people received placebo. Okay, so we know our total for the vaccine has to be 100. And we know our total for the placebo has to be 100, right? They said that's the total amount of people who received each. All right, let's keep going. At the end of the study, 18 of the patients received the placebo, and 9 of them who received the vaccine had influenza. Okay, so we know 18 got influenza from placebo, from not doing anything, and then 9 of them got influenza when they got the vaccine. All right, so now we just have to do basic math. 9 plus what is going to give us 100? Well, this is going to be 91. Now, 18 plus what is going to give us 100? Well, this is going to be 82. Okay, so now we have our box made, right? Well, they asked us for the relative risk. So what is relative risk? Well, in the relative risk, they said, well, how do we know it's a relative risk? Well, because they're testing between future and not future, right? They're testing in the future what happened. So they saw the 18 out of 100 patients or 9 out of 100 patients, and they saw to see if they developed influenza or not. They didn't have it before the study started. They only developed influenza after the study. Okay. What was our equation for relative risk? Well, we said it was one number over two numbers, right? So A over A plus B, for example. Okay. Now, the question, which of the following best expresses the relative risk of contracting influenza in those who received the new vaccine? So it says received the new vaccine compared to those who received the placebo. So it's going to be vaccine to placebo. So how are we going to know what's on top or on bottom? Well, just read it from right to left. Vaccine up first, vaccine on top, because they said receive the vaccine, over placebo on the bottom, because they said compare to. Okay, so what is going to be the top? Well, if it's two numbers, and we know the top is the vaccine, we're going to do 9 over 9 plus 91. That's how we get the top part. And now the bottom part is going to be what? Well, the placebo side. 18 over 18 plus 82. Not too bad. And now, I don't know why, but come tests and stuff, I kind of like stress out with calculations. So just go very slowly. Go 9 over 100 over 18 over 100. And now don't put it, I don't know, I put in the calculator as one big thing and I usually mess up. So just break it down individually. 9 over 100 equals what? 0.09. 18 over 100, I'm putting in the calculator, is 0.81. Now, put it in the calculator again. What is 0.09 over 0.81? 0.09 over 0.18, I'm sorry. 0.09 over 0.18 equals 0.5. So we're going to know our relative risk right here is going to be equal to 0.5. So let's go back to the question. Which of the following is our relative risk? Well, relative risk is going to be 0.5. Now I also wanted to talk about I just wanted to do odds ratio. So now if we're doing odds ratio, what are we going to do? Well, odds ratio was what? Well, one number over another number. And if they asked, what is the odds ratio of contracting influenza in those who received a new vaccine over those who didn't? Well, those who received it is going to be 9 over 91, right? That's the vaccine, over the placebo, which is going to be 18 over 82, because this is the placebo. And they're just asking, what are the odds? The odds of what? The odds of developing influenza if you get the vaccine, or the odds of developing influenza if you didn't get the vaccine. Okay. So now we're going to break it down again. 9 over 91 equals 0.098. And then 18 over 82 equals 0.219. So now we put in the calculator again. 0.098 over 0.219 is going to equal 0.447. So 0.45. So the odds ratio is going to be equal to that. So if we go up here, this is going to be the odds ratio. So that's really how you just determine odds ratio or relative risk in a question. Just take it slow and you got it.